I just now learned how I could send unreleased versions of hyperPad on my iPad, so I can record some cool unreleased features for you guys. In this video, I'm gonna show you guys one of the coolest features I've been working on for the past few weeks. So, what the frick is a noise map? Imagine an infinitely large 2D square grid of values that randomly range from -1 to +1. We can visualize this by mapping the values to black and white, where -1 represents black, +1 represents white, and all values in between represent a color in between black and white. This is a noise map. The special thing about noise maps is that the values smoothly lerp or transition from place to place, so you don't get very sharp changes. This is useful for things like procedural generation, which games like Terraria and Minecraft take full advantage of. The height of the terrain in Minecraft is actually determined by noise maps. The brightness of each value in the noise map determines the elevation of a block in the terrain. You can see how the terrain is relatively smooth and natural looking but chaotic most of the time, which is what noise maps offer. The biomes are also determined by noise maps, where the brightness of each value determines the temperature and therefore determines the biome to generate. Noise maps can also be 3-dimensional, which is perfect for Minecraft's cave generation. You can see how changing the Y position of the noise map is like moving through it. I use GK Noise from Apple's gameplay kit for implementing this feature inside hyperPad, which for some reason has the Y and Z axes swapped, but whatever. You can read more about Apple's implementation on noise maps in the description below if you want. Cool, let's move on to the fun stuff. Let's see how I've implemented noise maps inside hyperPad. Of course, all of this is subject to change since this is an unreleased feature, but might as well show you guys what I've been working on. I already showcased this feature on the hyperPad Discord server, so if you want to join that and see some exclusive content, the link will be in the description. Moving on, I've made 2 new behaviors, get noise value and noise map. Get noise value is simple. You can select a noise map to get a value at a specific position. There's only X and Y here since noise maps are 2D inside hyperPad. So technically, this behavior is reading from my 2D noise map, which is a cross-section of a 3D noise map. If that makes sense, I don't know if you guys get that. Now, the noise map behavior is crazy. You can create or manipulate a noise map. There's just so many features crammed into this one behavior. It's probably the most complex behavior you'll ever see in hyperPad, no joke. This right here is the preview, which updates in real time. How crazy is that? You can change the preview size, which visually changes the zoom on the noise map. It doesn't affect the actual output of the noise map, and it's just a thing in the editor. I kinda had to write my own shader for it, looping through every single position that's in the image and then writing the individual pixels. Yeah, I'm not sure if that was the best thing I could do, but yeah, that's why this feature is not released yet. The other developers have not even seen this feature yet. So I'm gonna send Hamid and Murtaza this video and see how they react. You guys get to see new features that I add into hyperPad before they are even out. That's just awesome. And you guys can also send me bug reports and feature requests in the comments below or in the Discord server.
And no, hyperPad is not coming to iPhone or Android anytime soon. Stop asking me that.
Alright, back to noise maps. Right now, the mode is set to create noise map, and here you can select which noise type you want to use, each having their own unique properties you can modify to make them look different. We have Perlin noise, which is probably the most widely used noise map, Billow noise, Ridge noise, Spears noise, Burnoid noise, Cylinders noise, Checkerboard noise, Ballsack noise. I'm joking, that one's not real. And finally, constant noise, which is just a noise map with only one value. Cylinders noise and Spears noise may look the same, but they're actually structurally different. Cylinder's noise is made out of cylinders, and sphere's noise is made out of, guess? Spheres. Let's get another noise map behavior, and in this one, let's transform the original noise map. Here, select the noise map you want to transform. Then you can scale, rotate, and move the noise map in 3D space. Cool. Let's see how it's like to move the cylinders and spheres in 3D space. Moving a cylinder noise through the y-axis visually looks the same, while moving a sphere's noise through the y-axis visually looks different. See? They're different. Well, let's move on to the next mode, which is colorized noise map. By default, the image is displaying black and white, but you can change the colors at the minimum and maximum values to be any color you want. In the future, I might have a way to add multiple colors. This is useful if you want to use a noise map as a graphic, which can be retrieved using the load image behavior. Load image has a new load type called noise map, where you can select the noise map behavior and define the resolution and rescale factor. The rescale factor is how much to shrink or enlarge the noise map. Changing the rescale factor does not change the resolution size. Moving on to the next mode, we have math operation, which performs a math operation on all the values in the noise map. You can see all the different functions we can use. For example, if I invert the noise map, you can see the colors of the noise map being swapped. In the background, this is just flipping the sign of each value. Negative becomes positive, and positive becomes negative. Cool. And the next mode is combined noise maps, which is kinda similar to the math operation mode. This performs a math operation on each value using a corresponding value from another noise map. So this operation takes two noise maps. I'm going to create another noise map. Let's use a checkerboard noise map so we can easily see the effect. Now back to the noise map we were originally on, we can select the checkerboard noise map as the second noise map. And you can see all the operations we can do. Noise! The last mode is distort noise map. This distorts a noise map by shifting values. We can apply turbulence to the noise map, and we can displace values in the noise map. Oops. This one uses 3 additional noise maps, which can be used to change the X, Y, and Z positions of the values. Awesome! That is everything about noise maps. Yeah, of course, like I've said earlier, all of this stuff are subject to change, but it is cool to see it all working before it's released. Moving on to the more fun stuff! Let's see the cool things that you can do with noise maps. I've been playing with noise maps for about 5 days now, and here's what I've made so far. I've created an animated lava texture using noise maps. I made this using 3 different noise maps, which are all changing translation every frame. Here, I combined all the noise maps together to produce the final result. Very cool. Oh yeah, you can chain up to 100 noise maps in series, which is crazy. Yeah, I set 100 as the limit. I don't think anyone's gonna use that much. The next thing I wanted to try was procedural world generation, like Terraria. Here is a very early prototype of what that looked like. It was very simple and very laggy. I did not optimize it at all. The way I did it was by moving all the blocks on the screen to their correct position, then reading values from a noise map, and then finally hiding or showing a block at a position depending on the value of the noise map. If the value was positive, show the block, otherwise hide the block. I made it flash green when the block was updated, which was all of them. So yeah, it's very unoptimized. But now, fast forward to present day, when I'm recording this right now, and I made a very simple cave game using noise maps. There's caves, vegetation, ores, biomes, and some small structures, and yeah, I even added lighting to this game. Honestly, it's not complete yet, but this is all the progress I've made in 5 days, so let's see how this works. You can see here all the noise maps that are used in world generation. A noise map for the caves, a noise map for every single ore, a noise map for all the vegetation, and a bunch more. The way I've made structures was a bit complicated, but you don't need to worry about that right now. So yeah, it's just a bunch of noise maps and reading values and checking if the value was positive or negative, or at some random number. Yeah. Yeah, the way I got this to work was pretty crazy. Anyways, I'm gonna go now, so enjoy the gameplay, and I'll see you later.
Bye!